he started speaking German. But when I started, I need to start with kindergarten books, and I feel stupid, very very stupid. I do all the mistake which any toddler or anybody, any kid will do when he's starting in the language. It is just that his attitude, or he is designed for this. For me, after learning, after investing so much thing, after seen as expert in certain technology, now I am feeling stupid because I'm pretty new to that thing. This is what exactly gonna happen with you guys. You will feel stupid when there is a new concept and you don't understand it. But hey, this is just a phase. This is just a phase in learning. When you feel stupid, when you feel uncomfortable, it's good. Something is working. You don't have to judge what is it. Is it your capability? Yes or no? No. Just realize that it is normal. It's very normal to feel stupid. It's one of the phase. We all feel stupid at some point. I will feel stupid if I want to learn something new. I'm feeling it for German for now, for example. So it's one of the phase. When you feel stupid and you still continue, the next step would be what? You feel comfortable with it. But it needs time, gradual, yeah? Gradually it will happen. So don't worry about feeling stupid. It is just part of this, yeah? Because most, like some of the people will say, hey, I can't understand it, so I'm dropping. Please don't do that. Most of the success is about showing up. Don't give up. You need to decide today that whatever happens, you want to be around until all of this series is done, and until Deepak says, hey guys, you are done now, you are set. Until that time, you will realize when you will be like more than, when we will finish around what, 16 sessions, I am 100% sure you will be more, you will start seeing new yourself. This is my expectation. This will happen. But until then, please hold on. Please don't listen to anybody. Please hold on. This is what I am requesting here. That's very important. Support each other. This is what I said. We want to create a private society here. We want to have a society which is, thinking brain, with no ego. I mean, we can't really get rid of ego, but ready to help each other. That's the whole idea. And any a junior engineer can refer 20 years of experience guy in any company, and still HR will look at it as if it's referred by expert, because they don't go and check who referred. They just say referral is coming within organization. It's very important thing to focus on this. Hence I always said creating lobby is important, and that's what we are building here. It's just not about the knowledge, it's also about creating this private society. So we hold on our opportunities, and we make sure our guys get those opportunities. That's the whole idea. Also, now, as most of you are coming from and identify yourself as a beginner, foundation is very very important. If you don't understand foundation, there is no way we'll be able to build a multi-story building. Yeah, so foundation is important. It's essential. Anything, any concept which you don't know, it's your responsibility to say it out loud, to ask a question. Yeah, to ask me. You can message me, you can send me anything. I am up for it. I will support you with some with all I can support for. So let's say some concept of cloud which you are not able to understand, the best idea. And instead, like for example, here we are discussing the approach, but you have some question which is not related to the approach, but you don't want to speak and you don't want to disturb the flow, just put it in the chat. I have this pen and paper, the iPad. I'll take a note of it and make sure it's covered at the end of the session, or in the next session, or one-to-one. That's the idea. These sessions, for now, you have seen it. It's more about aligning this. Today and tomorrow, the sessions are very slow pace. We want to feel comfortable here, but once we start focusing on concepts and technologies, everything would have. So 40%, I'm saying 40% because I want to cover myself. It's around 35%. It's gonna be theory. Rest of it's gonna be practical. I want most of you to start doing. When you do yourself, you learn better. That's the approach we are gonna take. And yes, a lot of stories from the field. I am fortunately I'm really fortunate to have a lot of opportunities to travel as a consultant. Half of my experience was it has been consulting, mainly facing customers, doing deployment, traveling site to site, doing things like that, or technical consultation, presenting something, architectural things, and like that. So, a lot of fascinating stories from field which we will employ here to explain the concept and also to keep the momentum. This is your responsibility. So you have paid for this course. It's not free, I understand. When we say money, it's part of your life. So if you are working for, let's say, a month, you get X amount of money and you have paid, let's say, 20% of that X, you have given me 20% of 1 month, that life, right? So I want you to make sure whatever you paid for, you are getting that value. And I am 100% sure you will get more than that, and that you will confirm after this series. But for now, if you don't get anything, if you don't get any keyword, I'm gonna use keyword like NFVI, Vim, SIM, or southbound, northbound interface, yeah, or orchestrator, hypervisor, anything which you don't understand, any keyword you don't understand, or even if you don't know the spelling of it. Sometime I would say something hypervisor, if it's new, I don't even know the spelling, let's say. What I will do, I will simply write whatever I can in the chat, immediately put it in the chat. Don't feel shy, don't feel bad. The more you ask, the more clearer it is for all. It's just not for you, it's for everybody. It will help everybody. So don't hold it. When you feel there is a keyword or concept which you are not, which you didn't get it, or you do not able to understand, put it in the chat. Put it in the chat. So I'll record it. Recording for 2 weeks, as I mentioned. All of the sessions are being recorded. You will have access for 2 weeks. On demand, it can be extended by a week or so. Last, this is a humble request. All of it takes a lot of time and investment from all of us. And hence, please do not share the content. That's a humble request. And I believe we all are very much rational here. I don't even have to, um, um, let's emphasize on it. That's there for now. As we are going into the Telco Cloud section now, are you guys comfortable continuing this right now, or how your schedule looks like? We do have 43 minutes, in my opinion. Yeah, around, not 43, but yeah, 32 around minutes. Are you comfortable going into this session? It's gonna take us exactly that much, 30 to 40 minutes. Okay, sure. Awesome, awesome. Great, great. So what is Telco Cloud? Start very fundamental, very, very fundamental. Yeah, I mean, just start from the beginning. Focus on human. Now, let's consider, start with human. Humans, they have fundamental needs. Like any human needs food, water, and home. These are fundamental needs of human, and it's essential, right? And there are now newly introduced needs. I would say we also consider them as fundamental, at least in developing countries. And so, and in developed countries, you might have some other. Sorry, I'm coming from developing countries, so I'm just having it here. Electricity and also internet is also considered as now. It's very basic, and everybody should have it. There is no rigid definition, but humans, they have a fundamental need. She will need food, water, home, electricity, and internet. Similarly, if we consider application now, there are words and keywords, and there are some keywords which I'll explain. There are some keywords I'll say for now. Just remember, and then we will go and explain and go deep on that. Yeah. So human, we know they have some basic needs. Similarly, any application, when I say application, is any program, Facebook, yeah, Instagram, Google, Gmail, yeah, this Google Meet, any application, any software program, any process, anything which run, which is any application, let's say on your mobile, or any kind of software, also has some very fundamental needs, basic requirement. One of it is processor. Processor process the information. Yeah, it's also called CPU, central processing unit. Processor process the information, but hey, processor is very fast and it needs information almost immediately, and hence we have something called RAM. It's a random access memory. You don't have to recall all of it. Processor, memory, because processor want to process, so it does the calculation, and your memory holds the data, but it's very fast so that it can cater CPU faster. Yeah. So what happens? Your application code. This is Facebook here. It can be 5G. It can be anything else. Yeah. So, sorry about it. Yeah. It can be anything. So any kind of application needs processing unit, also need memory, because processing unit does calculation, memory holds or load the program into it. So your Facebook will be loaded to a memory on the server, and then it will be processed on this processor. But when you save something, when you upload your photo, that goes to SSD, or let's say that's a storage. It can be SSD, HDD, or any kind of other storage. Yeah? There are a lot of options in storage also. For now, it's a storage. We call it persistent storage. Why persistence? Because the data persists there. It's not something which I save and it's gone after some time. No, it will be persistent storage. So data stores and gets stored on the disk here. So again, application uses processor for processing it, and processing is very simple word, but a lot of complex things happen, mainly calculations of some sort of calculations. Yeah, at machine level, let's say machine level, you know, the binary. I'm not sure if you know that, but we don't even have to go that level. For now, you just need to consider that any application, it has a basic need. One of it is the processor, memory, very fast, so that this application can be loaded into the memory and catered to the CPU, and that's how it will work. Whatever information you want to save on Facebook, for example, will be saved to the persistent storage. And obviously, Facebook is social app, social, right? You need to connect to other, and that's where you will use network. And we will again go, when we do practical, we will see all of it. We will see how many processors are available on that system, how the memory looks like, what is the size of memory, what type of memory it is, what type of persistent storage we have, what kind of interfaces. When I say interfaces, is what network interfaces, what kind of network interfaces we have, and things like that. But hey, can we have application without network interface? Possible, right? I mean, there are programs which runs without. I mean, there are some introvert program. For example, washing machine. It washes the clothes, not necessarily connect to outer world, right? Its programming is done only to wash the cloth. The programs are, written on a persistent. It can be disk, or it can be very small chip, right? Because you don't have to have a lot of capacity, so it can be a very small chip. It provides you 4 or 5 programs, and there is a processor to control, sense the sensors and control and things like that. That programs, the washing machine program runs within washing machine. It doesn't go out, and hence no networking is needed. Similarly, there are use cases where some part is needed, some part is not needed, right? Just like humans, some humans don't. I mean, this is needed for everybody, but there are a few things, like some of the people, even now in the world, they are without internet. So if they see that there is no need, that facility might not be there, for example. So you will sometimes see that there are few devices which are without networking here, but generally you will see processor, memory, storage, and the network is the fundamental need of any application. And that's now, if you put an application on one server, you are satisfying all of this need. Let's say that server has processor, memory, and storage, and also network. You have satisfied the requirement of one application, but let's say the application is bigger. Now what will happen is you need to have multiple servers in order to serve the load of the application. And the more people you're connecting to Facebook, the more server you need to cater the requirement. And hence, now the servers are physical boxes. They are connected with wire, let's say, to network, to a fabric. And I will explain that how it looks like and other things. But let's say for now, it is connected to other servers. So each server is connected to each other. They can see each other. They are on the same network. So although they are on the same network physically, they can see each other physically, there has to be some kind of software which manages those. Yeah, the software which manages this connectivity between the servers, in our case, in this course, is what? It is Kubernetes. But you don't have to associate anything right now. Just see it like this. You have your Facebook or 5G. For us, until now, it is the same, because we are just talking about basic needs. We are not talking about other requirements, specialized requirements, right? Just basic need. Now my Facebook, or let's say an application, was running on one server. It was providing processor memory and the storage and also network. But now the application needs more capacity, and hence I need more servers, and more server needs to be connected each other at software layer. They need to be managed by one entity, and in our case it's gonna be Kubernetes. For now, there is nothing more than this. You just need to understand very fundamental thing. So now, in order to connect multiple server together at software layer, we are using what? Kubernetes. And there are a lot of other things and within Kubernetes to learn. For now, we will just see that Kubernetes create a virtual layer on the top of physical server. So when I connect all of these servers together using Kubernetes or similar platform, or let's say similar software, I'm calling it software here, similar software, what happens is this application don't see this one server. It does see it, but it also sees something else. So all of these servers together create a pool. Now the application don't have to see one CPU coming from this server, this server, and this server. No, it will see CPU coming from all of these three. It's because of Kubernetes. You will see them as a pool of resources, and then the Kubernetes can decide where I want to put this application. But hey, that's coming later. So now you just need to understand any application has primary or fundamental needs: processing, memory, and persistent disk or storage, also network, will be satisfied by one server if it is very small application. But if we have a bigger application, we need multiple servers to satisfy this need. All of this server should be connected at software layer. You can connect it with wires, but they won't work. They need to be connected with software. That's today, in our case, is Kubernetes. Now, if I put all of this server in one data center, but in my data center, and what is data center? Now, this is the keyword, guys. If you don't understand any keyword, put it in the chat. Put it in the chat. Let me see if I have something in the chat. Tomorrow onward, I'll have another. Okay, nothing. Exactly. Basically, it does abstraction of underlying hardware. Kind of, yes, kind of abstraction. Yes, very good word. It does abstraction, and it creates kind of a pool. So then the application or a team deploying the application don't need to consider if I have certain, the capacity available on one server. It's a pool. As long as I have capacity in the pool, I can deploy it. I can install the software and it will run. For now, I'm not going into terminologies of Kubernetes just because we have very beginner people here, and we want to support everybody here. Certainly, we will go in deep. Yeah. Okay. Awesome. Mm, Now let's consider. Now coming back to the human. Uh, she's done now. All basic needs fulfilled. She's not hungry no more. Yeah, she's very fresh now. Everything is fine. Now she need to have the electricity because she wanna access internet or she wanna do something. There are two ways to have it. She can own. She can build her own power station. Yeah, but and it's possible. Yeah, today she can build her own turbine, small power station, and utilize it. But today when we see it, we say, oh, this is weird, right? What we do is what? We just get a wire, a connection from electricity provider, and we start using it. Keep it in your mind. If she decide to build it her own turbine, it's gonna take a lot of money. It might be easy maintaining later, but it's going to take huge amount of investment in the initial, and hence she goes for the model called pay as you go. She goes for connectivity. She goes for existing electricity provider, go and get the connection and start using it. She don't worry where it is where it is generated, where it is stored, how it is distributed. It's all that electricity provider's job. Come this side now, our application. The fundamental needs are there, and we now understand that those will be satisfied by the server, and all server together, Kubernetes is creating a pool of resources, right? So processors, memory, and storage is available in our pool. If I have two options now, I can build my, I can literally compare it with Turbine. I can build my own number of servers. Let's say I can buy them, stack them, install Kubernetes, and do it in my home or in a certain place. Let's say if it is organization, yeah, most likely it's gonna be organization. So organization. So within our office, it is going to be called private because it's my own. So this lady, she built a turbine. It's her own. It's a private, but it's not that feasible for her. So she is going for connection from the electricity provider. What I'll call it, that's a public, right? So if I decide to host my Facebook or my 5G, not in my own server in my premises, but I decide to do it in someone else's premises, that's what public, and that will be distributed via what? Internet. You are connected to the outer world via internet, right? So if you decide to host your application on one server, on number of servers, they are connected using Kubernetes, uh, and there is a pool of resources. You decide to host that in private in your data center. It's a private cloud. It's a private cloud. Now there are a few keywords which I would like to highlight. Private cloud is a keyword. It's a private cloud. But hey, I don't want to keep it's too much investment for me. Instead of doing that, what I want to do now is ask someone, go and ask Amazon. You guys, some of you already are certified. So I'll go and ask Amazon or Azure or anybody who is providing me the server because I want to run my Facebook or my 5G. I'll say, hey, I have an application and processor, memory, and disk and network. This is the requirement of this application. Yeah. So please give me a number of servers, or I would not even say number of server. For me, I don't care. I just care about processor, memory, disk, and network. I need, and we call it, what is it called? Resources. Resources. CPU, memory, disk, network, those are resources. Resources is a keyword. Resources is a keyword. You will hear it again and again and again in this session. So, hey, I will go talk to AWS and I'll say, hey guys, I have an application called Facebook or 5G, and I want to install it in your data center and access it via internet. So I will call that model as a public cloud because what it is publicly. So somebody, some organization, in this case AWS or Azure or Google, they have their data center and they are saying, hey guys, we are available for rent. You can also compare this with hotel or let's say with hotel, let's say, where you have a building ready and you go there, you rent a room in it for a month, let's say. You stay there, you access all the shared resources, shared services, swimming pool, lobby, yeah, restaurants, bar, anything, and then you pay for the room. Once you are done, you go home. No more obligation, right? You don't need to consider building the whole hotel. This is the same concept. In our case, we had an application with certain resource requirement, then we talked to Google or AWS and said, hey guys, I have this requirement, but I am not comfortable building my own data center. Data center is what? Data center is a center where you have a lot of servers or a lot of capacity to run this kind of workload. So it can be my own if I have my own servers and my own setup, let's say, but it can, and that's called private cloud. But if it is someone else, I'll call it public cloud. In this case, in this example, she said, yeah, it's too much work to go and build own turbine, and yeah, it takes a lot of efforts, and Capex is a capital initial. It's a capital expenditure, right? The initial investment which you do, and the OPEX is the operational, expenditure which you need to um, put on the table to get the support, let's say, or to continue maintaining, or to maintain it for that certain amount of time. So in this case, she said, yeah, it's better to go for pay as you go model. So she talked to electricity provider, get her electricity, and she started using it. It's very simple. The model is pay as you go, so you don't have to go and pay from the beginning. The initial investment is very low, very low. But yes, you have monthly bill. So based on your consumption, you will get monthly bill, and you also have some additional services. Why? Because think about AWS, Google, or Azure. They have a service called, we will go to that service, but for now forget. They have some kind of service which will allow you to host your application into their cloud, and that's a service. They are building it for the world, not for you, for the world. So obviously they have so much money coming in from the world, or all around the world, and they have enough money to put it into research, to automate things, to improve the quality. And hence, when you compare your private cloud deployments with public cloud, you feel inferior in case of private cloud, because private cloud, you generally have budget in millions, and AWS spend billions, for example, on automating and perfecting their solution stack. So it's always like that, because you are creating private is always very limited in size versus the public services, right? They are mostly serving mass population, so they have good amount of money to invest to improve things. And that's why public cloud seems superior, or it seems it's superior. It's just because of the amount of money and budget they have for that, and also great talent around it. So do you have any question on this one? But let me perfect it, or maybe discuss it more, and then we will come back to the question. I have an application. I hosted it in my home, my data center. I got some servers and I installed them, connected them at software layer using Kubernetes. Sorry, I just need to see somebody facing issues or what. Yeah. Okay. Okay. No worries. So the thing is, if I host all of it, then it's like my home, right? It's my home, or it's like my data center, as it is owned by me or you guys. Let's say you are own. Obviously, it's my home and my rules. I have full control of it. So my data, where to keep it, how to secure it, access control on things, it's completely in your hand. And hence, private cloud is always considered very secure, because you can literally isolate it from the world. You can say anything coming in, will come via firewall, or let's say only incoming traffic is allowed to certain DMZ zone, right? Keyword DMZ. It's demilitarized zone. So it's a zone where internet traffic will be terminated in your data center. When I say data center, imagine a room with full of servers stacked and rack and stack together, and you will see blinking lights everywhere. Imagination is, we need to put at work here. We need to really imagine. There are some concepts which we cannot touch. They are not tangible. What we can do is we can create an image in our brain. I will try to make it more visual as much as I can, but if I cannot, then, or there is some limitation again, we need to put our imagination at work here, and we will do it together. So now, number of server connected together using Kubernetes in my own data center, in my own room, I will call it a private cloud. Yeah, Kubernetes create a virtual layer on the top of it. So servers are connected, and I'm installing Kubernetes. Now I'll have a virtual layer. Now, what is virtual? Virtual is means what? Not real, right? That is not a physical. It's like an illusion of a layer where application will see unlimited capacity available in the cluster, but actually it's not. It's limited server, but for application you have capacity. So We'll go into more details when we do hands-on. For now, just understand, when you buy your own server, install them in your data center, you or your organization buy them, install them in your data center, your own data center. They are not directly exposed to internet. They are in your private premises. That is called private cloud. These are some basic concepts which we need to, tick mark before we go into our discussion, so that we don't let's say get confused with terminologies when we start using them frequently. What is public cloud? We said public cloud is almost equivalent to what? In this case, it was my house, so I bought this house. I bought the house. It's my house. And the public cloud is what? I will rent it. Public cloud is almost the rent. So I have a 5G and this Facebook application. I need the fundamental needs of it: processor, memory, and disk, network. I can fulfill them in private cloud, but I have decided to go ahead with the public cloud provided by Amazon, Google, or Azure, let's say. It's equivalent to what? Renting it. So my application will get a room, one room in this storage, or one place, or I'll get a resources on rent to run my application on one of the server, or let's say in the, this is, they are also running some kind of Kubernetes, and we will get to know that later. But whatever stack they are running, will get space here. At the end, we just need these resources to run this application. Those will be hosted here, exposed to internet. Expose is the keyword. Okay, expose is the keyword, and it has meaning to it, even from Kubernetes perspective. So now, expose is what? Exposure. I get exposure when I go to something, right? So these services, my Facebook and 5G application, will get exposure to internet, controlled exposure. I'll make sure the policies are in place, but I want to expose it to users so people can use Facebook. This is the idea. And in this case, as it is hosted on the on someone else's premises, but I'm accessing it via internet. So think about it. Somebody is creating, or it's maintaining a compute power. Now I will call this, if I want to name these resources, not say four resources always: processor, memory, disk, and network. If I want to use one word for it, what I'll say compute. When I say compute, is also equivalent to server, also equivalent to worker. Yeah, these are the keywords you will learn slowly. You don't have to remember everything. You will learn slowly. I'll always repeat it. And as we agreed, anything, any miss, put it in the chat. Okay, so I'm saying compute. So yeah, this is the idea. This is like renting it. This is, yes, so it's like a renting. I'm not gonna get the house here. What I'm gonna get is, I just need a compute capacity in this public cloud. I'll get it from here. I'll expose my services. So compute is maintained by that organization. Capacity is maintained by that organization. Internet is a medium of distribution, right? So electricity is generated by someone. The electricity pole, the distribution is happening via the wires. You can see the high tension wires, right? Happening via the wires, and it's reaching to me. So in our case, compute is maintained by AWS. Internet is a distribution medium to consume the services. And as those services, which I'm saying in public cloud, are there, I'll call them public cloud services, because those are publicly available via internet, hosted in someone else's premises in AWS. For me, those are public cloud. Yeah, those are public cloud services. So it's equivalent to rent. Now, there is a new concept called hybrid cloud, and this is very, I would say, it's a sweet spot for telecom, especially. Why? See, in telecom, they need to own their house. They're like, there is no way a telecom will not own a data center. They will have to have, like, the footprint is so huge, they will have to own it. Why? Because of the nature of the application. Like, core is not gonna grow by 50% in 1 year, right? Core will not grow by 30% in 2 days, right? It's not a elastic. So it makes sense, instead of paying rent for a huge compute capacity. And when I say compute, is what? Processor, memory, disk, and network. Compute capacity, such a huge compute capacity for any telecom provider, it's not possible to host it in public cloud. And if they do, it's going to cost too much. Every month they will see millions in bill. Yeah, and yearly it's going to be billions, let's say. But Hence, it makes sense to own the house. But hey, why to own a bigger house? I can say I can identify, or we can identify static workload, and again, keyword workload. Application, bunch of application we can call workload. So in our case, it was 5G and Facebook. So 5G is not elastic. It cannot grow in the night and it cannot shrink. So for example, um, take an example of Amazon website, where let's say you have a Black Friday sale. Suddenly whole world start accessing it. So it grows, right? That night they will need more server. It grows in the because the number of people are huge that day they are purchasing. But that's not going to happen. In our case, you need to have core or your network oversized. You need to you don't need to wait until it happens. You need to just say, okay, it's gonna be Christmas, it's gonna be Eid, it's gonna be Diwali, it's gonna be something, and that day people will start calling each other and the traffic will be huge. You need to consider that beforehand and make sure that the static capacity is there. ISP network is always over provision most of the time. Yeah, always over provision based on the number of customer you want to support and the subscriber you want to support on the network. Again, any keyword which you don't understand, please put it in the chat. So in this case, I have a static need. So I am buying the house. I am saying this is my private cloud. I will host all of my static needs in the private cloud. But hey, I have a function now. I have new guest and consider this guest as new applications, and I want to support them. I want to host them. What I'll do, I'll go and rent another house. Yeah, feasible. We don't nearest house, let's say. So I can simply use the same terminology. I have my data center where my services are running, but hey, I have a new project where I need to test something, and for testing I need to spawn similar network, but it just need to be there for a month, let's say. Instead of creating a new data center, hosting everything there, investing so much money, I can just go to Amazon and say, hey guys, I have a requirement for testing. I need it for 1 month, and hence I need to rent your compute resources for it. And they will say, yeah, why not? And hence this hybrid cloud is really best in, best from both worlds. So it's really one of the best option and architecture to consider in such telco deployments. But in order to do that, it's not that easy. You will have to have network connectivity between your private data center and a public data center. This is a topic for which is very advanced in my opinion, and we will discuss this certainly at the end of the series. Let's say where we discuss the integration or migration of your telco cloud workload from private to public and public to private and things like that, vice versa, let's say, and also data flow. Uh, so we will discuss that later. But for now, you just need to understand that this is a popular service and it's a type of cloud. So what we discuss, this one. We started from private. Private is what? Like owning your own house. You own your house, meaning you own your compute, your data center. So it's owned and managed by consumer. We are a consumer here. It's owned and managed by consumer. Obviously, as it's ours, we have greater control. We have security. We can isolate it from everybody. We can decide who can have access to it. Also, you can do a lot of customization. You can write your own script. You can do it in your way. It's tuned for your needs because you are paying for it. And there is another one, public, which is managed by third party like AWS, let's say. Services are hosted somewhere else. Distribution medium is your internet. You are accessing your services from internet. The model is pay as you go, no initial investment, very little, but you will get a bill monthly because, based on your usage. That's equivalent to renting the house, not buying, not renting. And the sweet spot, which I love and I always recommend, that is hybrid. Leverage benefit from both cloud. You fix your whatever application that they will not grow, or the capacity requirement will not be there will not be a spike of 50%. You can easily size them and put them on your private cloud, because comparatively public clouds are way expensive, at least from communication provider perspective, from telecom side, because our workload is most of the time static and oversized. Yeah, so for example, it makes sense to keep core in private always. Although there are a few examples, Dish, for example, everything in the cloud. Even core is running in the cloud footage. So makes sense in my opinion to put keep that in private, but in public, for example, testing environment, yeah, for example, some services which don't need special accelerators, and we will go into that discussion, what kind of accelerators we need in order to support telco cloud workload. This is a complete one session. We are going to go there. It's a part of advanced. For now, we will just say whatever application I can run, or we can say lightweight application. It can also say, we can also say non-telco application like IT, like for example OSS, for example PSS, I don't know. Any application which does not need special accelerator can go to public cloud. Or testing can be public on public cloud. If we combine both, if we create some kind of network connectivity between both, and if people can drag and drop between private and public cloud, it will be so easy, and there will be a capacity elasticity always as an option available. Also, when you have part of your deployment running in public cloud, you have a lot of innovation happening in public cloud. Sorry, my bad. Just okay, so a lot of innovation happening in public cloud because of the budget they have, and that you can extend in your private cloud by opting for hybrid model. Um, Now, I would like to highlight a service model. Maybe this is gonna be a little bit difficult to understand, but let us try here. If you recall, I had an application, Facebook or 5G. The application is this one, yeah. Any application would need data that was stored on the disk. If you see, SSD was there, yeah? And that data and application together run some kind of program, right? If you're using Windows, when you do your task manager, you see programs running. So those programs, if you're using Mac, you can see an activity, yeah. So those programs will use some kind of runtime. For now, you don't need to go and see what is runtime. For now, you just need to say understand runtime is something which will help your program to run on certain operating system. Runtime is something like a libraries, things which you generally use for any application. So in for now, you can keep runtime as a word. I'm not gonna give you more conceptual. It is just that you will very rarely hear it, yeah. So I can add it in our, yeah, in our let's say, how does it communicate, transact between private and public time to time basis, the capacity requirement. Yes, this is very good question, Akin. We are gonna discuss this when we will discuss the network connectivity between private and public cloud. There has to be a connectivity. There has to be gateways both side, yeah, to have this connectivity. And there are other requirements. It really beg for a separate session. I'll have it written here, but please allow me to come back. This is advanced topic and should be covered somewhere else. Interconnect, yeah, no, not interconnect. It's a AWS uses, I think, direct connectors, connect direct or direct connect for such things. So now, please, yeah, you are welcome. So now, do not confuse with all of this fancy word. It's gonna come. It's gonna come into us. Yeah. For now, our application 5G and Facebook. Then you have a data in it, your photos, videos, or whatever. Then you use runtime. Runtime, keep it low level. Runtime is something which is like a helper function running on the particular operating system. You have middleware. Middleware is like something messaging or database services and things like that, where you handle the data or logic of the application. Anis, yeah, thanks a lot. Yes, it's direct connect. Yeah. So middleware is the layer where you handle your data. Now we are going into this application layer. We don't need to necessarily go here, but these are the layers which we need to understand. Not really that important, but it is important from interview perspective. We will certainly come back and visit this. For now, try to understand. Application would have a data, and the application, in order to run the application properly, you need runtime. This is a helper function which runs with the application, or it's available on the OS. Let's say you have middleware. It's like a messaging or some or a application logic or a database services are there. You have operating system. Operating system is like, I have a MacBook, I have a Mac OS. You have, if you have Windows, someone has Windows, he has Windows operating system running on the computer, right? Operating system is a software layer which manages the resources, the compute capacity, processor, memory, disk. Obviously, some manager needs to be there to manage this, right? And provide you. Yeah, that's true. Uh, Yes, Shah. Certainly. The thing is, there is a question: is public cloud security vulnerable as we have our own security in private? Yes, certainly. It's always like that, right? When people say security is physical security is the best form of security, right? But when it comes to private public cloud, I wouldn't say that's 100% correct statement. Why? Because now, so how somebody perceive that the security is at par or not? You have certain certifications for the organization. Even if you own it, you need to pass those certification in order to comply to the land of law, right? For example, some kind of certification. So what Amazon, Google, and these guys are doing, they are putting a lot of efforts to get certified on those, on with those bodies, and they will show you it. Our security is equivalent to your security. The only security concern we generally have in public, not from data center perspective, in public, is that public cloud is that you are sharing compute capacity from the pool. And it's not just you have thousands of other people or other organization getting the compute from the same data center. It means you have a hotel where a lot of people are coming from other places or countries, let's say, which is shared by everyone. And it is certainly possible that your noisy neighbor can impact your performance, or impact you, or there can be a security breach. Yeah, it's possible, and hence it happens most of. But now, if you ask me, like, recent issues were mostly about some misses and sophisticated, most of the time insider also impact this aspect. But yes, it is always considered that public cloud is less secure than the private cloud, but it's not the case always. Like in my experience, I have seen company name @123 password in most of the cases, which is so bad. Yeah. So coming back, I hope I answered your question, Shah. Okay, thank you. Coming back to operating system. So now we are at operating system. Um, Below operating system, there is a layer called virtualization, and this is a keyword. We will come back to it. But for now, you need to understand that if I have a server, I have a server. Server is a compute which provides a, so server, compute, worker, all same. Yeah, server, compute, worker, all the same. They are. You can imagine a hardware. You have a hardware box. You have CPU, memory, and storage in it, and you want to virtualize it. So how you want to virtualize it? By, and what is the virtualization? You want to create a layer. You are not in cloud yet. You, let's say you have one server. You don't have multiple server for now, one server, but you want to install multiple operating system on the one server. That is possible with installing virtualization software. So how many of you have heard of VirtualBox? Or maybe let me give you have Windows laptop. What if I say I want to install multiple Windows, one for me, one for my wife, one for my son or somebody? Yeah, I want to install. If that is the requirement, it's no more by the. Yes, for Saif, please. Okay, you guys have done this. Oh, awesome. So virtualization is a layer which basically gives you capability to uh, share the same hardware with multiple operating system. You can host multiple operating systems, and you have a lot of. It can also be called hypervisor layer. Yeah, we are gonna go there. For now, these keywords are important. We are gonna go there and discuss each of this word. For now, just understand. Um, it's kind of a software which will help you to share the same server with multiple operating system. How? By creating, let's say, a virtual machine on the same server. Then you have a storage and networking. It's actually one box. So all the hardware, this is a hardware component of the server. So this is the server. I have virtualization software on it. Then operating system. Most of the time, these are also club. You have operating system. That's called host. because it will host something. So it's an host operating system installed on your hardware, because it's hosting something. What it will host? Application. So if my application is coming with some its own operating system, it will be called guest operating system, right? I am hosting, hence I am called host operating system. My application will come with its own operating system, that will be called as a guest. And or if you are not using that, you don't want to create a separate server, let's say, then you can simply utilize OS and install your application stack on it. This is a private cloud where you manage everything, all the layer. You can see here, you manage all the layers. I think we are over time, guys. What do you think? I think this is gonna take another 20 minutes or so. Shall we continue here, or because I really want to make sure everybody is with us? I can see people dropping. I think we should move this to, yeah, it's late. I agree with you. Let us continue this then tomorrow. Yeah. I will stop here. The session will be recorded. It will also be available for you guys.